Next one, find the distance between Px1, y1 and Qx2, y2 when first part PQ is parallel to y-axis and second part PQ is parallel to x-axis. Before going to the question, if I am drawing x-axis and y-axis and if I am taking a point 2 on the x-axis and I am drawing a line parallel to y-axis through the point 2, can you say what is the speciality of the x-coordinate of this x-coordinate of the points on this line? All the x-coordinate will be 2. If I am taking a point corresponding to 3 on the y-axis, the point will be 2, 3. So if I am taking a point corresponding to y on the y-axis, it will be 2, 1. If I am taking a point against -2 on the y-axis, the point will be 2, -2. That means all the x-coordinate remains the same when we are drawing a line parallel to y-axis. Same way, if we draw a line parallel to x-axis, all the y-coordinates remains the same. Okay, so this is what we are going to apply here. In the first part, it is given that PQ is parallel to y-axis. And the question is to find the distance between P and Q. Distance between P and Q means it is PQ. By distance formula, we have square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. That's equal to, since the line PQ is parallel to the y-axis, what about the x-coordinates? X-coordinates remains the same. That means x2 and x1 will be same. So x2 minus x1 will be 0. That is square root of 0 square plus y2 minus y1 the whole square. That is equal to square root of y2 minus y1 the whole square. When taking the square root, we are getting y2 minus y1. And there is a chance of y2 minus y1 to be negative. But as PQ is the distance, it must be positive. So we will be writing the answer in the modulus of y2 minus y1 when the line is parallel to y-axis. In the second case, it is given that PQ is parallel to x-axis. PQ is parallel to x-axis. So here also we will be applying the distance formula. PQ is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. What happened? So as the line PQ is parallel to the x-axis, the line can be like this or somewhere like this. So since the line is parallel to the x-axis, its y-coordinates remains the same. Okay, so y2 minus y1 will be 0. So it will be square root of x2 minus x1 the whole square. Here also when we take the square root, it will be x2 minus x1. Since there is a chance of x2 minus x1 be negative, and since PQ is the distance of between P and Q, it must be positive. So we will write the answer as modulus of x2 minus x1.